Hi, in this video we're going to be looking at the atom, and it's going to be quite a quick video, so we're just going to quickly go through the key stuff. Now, I think our model of the atom is pretty well what you see on the screen here. So in our particular nucleus we have protons and neutrons, and around there we have electron shells. All right? The electron shells allow electrons to be at fixed energy levels, and we'll talk about the theory. Hopefully you've had a watch of some of those history of the atom videos I've got up on our page, so I hope that'd be good. So protons have a positive charge, neutrons have a neutral charge, and we call them nucleons. Okay, so they're referred to as nucleons, and then we have our electrons which have a negative charge. Now, when we start looking at our particular atom itself, our elements, now obviously in the periodic table we have all these elements there, and generally they have a capital letter followed by a lowercase letter, as you might have learnt in chemistry. We have this A value, which is our atomic mass number. Now, that is equal to the number of neutrons and the number of protons. And then we have our Z value, which is our atomic number, and that's equal to the number of electrons and number of protons. All right, so if we're looking at, say, nitrogen, so nitrogen here has, if we're looking at that particular value, would have 7 protons, 7 electrons, and because it's 14, that would have 7 neutrons. Okay, so that's what we've got there. Carbon 12, okay, that's got 6 protons, 6 electrons, and 6 neutrons. Okay, we've got to have the right number there. When we start looking at uranium, uranium-234, okay, then that's going to have 92 protons, 92 electrons, and then obviously it's going to have 142. So you'll find generally the bigger elements will have more neutrons than protons. All right, so looking over here. Now, we will talk about isotopes. Okay, you need to know what an isotope is. So that's an element with the same atomic number, but it has a different mass number. In other words, it has more or less neutrons. I just want to quickly talk to you about a couple of those key ones that we need to know about. So carbon dating uses carbon C612 and C614. Okay, so the idea of carbon dating, it uses those particular forms of carbon. So when objects are alive, or anything that's organic is alive, there is a ratio of carbon 12 to carbon 14. But what happens when they die is carbon 14 will decay back to carbon 12. So you can look at the half-life of carbon 14, and that will give you an idea about how old something is. Another one that we quite often use is hydrogen. So hydrogen there is our normal hydrogen, but we can have this hydrogen here with an extra neutron, and that is called deuterium. And then we have another hydrogen, another neutron, we call that tritium. So that's probably the things that you need to know. They are probably 3 elements that you will see that are quite important. When we're doing nuclear stuff, we're looking at heavy water. All right, the other one probably is most notable, I suppose, is uranium-92, 238. That's the normal thing of uranium that we'll actually use. And when you enrich uranium, you use 235. That's the one that easily fissions. All right, so an isotope is simply an element that has the same atomic number but a different mass number. Now, you would have seen these equations possibly in chemistry. All right, so we will get you to do this. And what we're doing is balancing the number of the atomic number and the mass number. So if we were looking at this side, the atomic number on this side is going to be, the mass number is 10. The atomic number over here is 5. So we're going to make sure this is going to have the same number. So obviously helium's 4, so I need this to be 6. That over there is 2, so therefore that needs to be 3. And that's now a balanced equation. The decay of uranium-238 to thorium, okay, again, we've got 238 over there, 234, so that's got to be 4. And that's got to be 2 over here. So this particular element here is in fact helium. That's a common one that you'll get to use in most science. Over here we've got 18 at the top, we've got 9 at the bottom there. So therefore this has to have 1, and that has to be 1. So therefore that is in fact going to be a proton, isn't it? Okay, or in fact we might call that, it's an element, hydrogen. Okay, so that is actually hydrogen. And then they're looking at the next one down here, balancing these things over here. On this side we've got 14, here we've got 7, so therefore that's going to be 1, and therefore that's going to be 1, and that's now balanced. Alright, so elements are really important. We need to make sure that we understand how to balance these things. That's certainly a really important part of what we're doing there. And the concept of the model of the atom obviously has changed over the years, as you've seen in those previous videos.